Okay, so yeah, let's create a order book. This would be good. So the way I see an order book is that there can be two different sizes of books inside. There will be a bid book, and these are going to contain all the resting bid offers that haven't been fulfilled or are yet to be fulfilled. And then we will have an offer book, which contains all the offer orders that have not been fulfilled. So these are the resting offers as well. One of the key characteristics that I see between either a bid book or a offer book is that when a new order comes in, we must, since a trade will always execute at the arresting price offer, which means that it will always benefit the aggressor, so that's who is coming in. It's really important that we ensure that we get the right price point for both the bid book and the offer book, because we're going to be using a price time priority order book where price is the first priority. It's important that we can get all the orders associated to one price point correctly first. So let's look at that in case for a bid book. In our bid book, the best price will always be the largest amount of price someone is willing to pay for a security. That is always going to be the best price possible, and that's the price that we'll always be matching to, given that there exists an order for that price. And for the offer book, the best price would be the lowest price possible. Let's say that someone put in a bid, so the aggressor put in a bid. For them, the most beneficial price for them would be a offer that has the lowest amount of money, such that they're able to buy the security, they're able to buy their quantity for the cheapest amount possible. So the way that I just explained it using a data structure, I think I can model the bid book using a maximum heap. I'll use a maximum heap for the bid book, where the best price, so the highest price, will be at the very top of this heap, of this balanced search tree. Whereas for the offer book, I'm going to use a minimum heap, where the best price, which is the lowest price, will always be at the head of this book as well. So that's how I'm going to do the price priority part of these books handling, where the head of the heap will always refer to the best price possible for the respective book. And then next we're going to do the time priority part. So for a time priority, I'm thinking we can use a simple list, because the order that we append to the list, so we're going to append orders to the list, will always be kept. So that's the way. So the first order that comes in will always be the first order to be popped out. That will get It's the first order to be fulfilled. So I'm thinking of a FIFO data structure queue, which is what I just said. We can use a queue. In Python, we can use the DQ model because this is a double-ended queue, and then this just allows us to pop from the front of the queue in a constant time operative, rather than, let's say, like a normal list where we'd have to shift everything back to the front. So here I'm seeing that we need to use two different data structures. We need to use a heap, which will keep track of the best possible price. And then after that, we can use a dictionary, which will have the key is the price. And then for the value of that dictionary, we can have a DQ, which is just going to be a queue of orders. For the price that we check, we're going to compare the price against the incoming. Let's say we're looking in the bid book, so we're going to be receiving a offer. So we're going to compare this best price that we have compared to the offer book, and if it is sufficient, so if the bid book is greater than or equal to the offer coming in, then we can execute these trades. And then we're going to execute these trades by going through each order from the start of the DQ. So that sounds good to me. And then the matching engine, let's say above, will so that sounds good to me. But first, let's go over some of the different type of trades that we're able to go through. So in the booklet, there are four different type of trades that we can go through. A complete execution, in this case, is where the amount of stock security quantity requested are fully completed with one order. Another case is as a partial execution, when only some of the quantity could be fulfilled for this given price point, but the rest couldn't be. So this would be added back towards its respective offer book. A total execution, where a incoming order is fulfilled across multiple different resting orders, and simply no order at all, where the bid book, where the incoming order's price, uh, the best price cannot match the incoming order's price as well. So those are the four things that I can see that I have to handle as well. Would it be fine to start coding now, or would you like to hear from me how I would possibly tackle those before I get into the code? Sure, yeah. So So the most important thing that I have to think about is that, yeah, so let's think about our first case where a complete, there's 100, there's a bid for 100 shares. That's a resting order, and an offer comes in which has the same price for 100 shares as well. And that price both will equal, and then at this point we don't need so nothing will get stored in the offer book, but in the bid book we need to delete this outstanding order because it has been fully fulfilled. In this case, if the remaining quantity of securities to be traded for that resting order is 0, we'll simply delete it from the queue. And after we've processed all the orders, we can simply check, does this queue have any items at all? And if it doesn't, this means that there are no more outstanding orders for this price point, so we'll be popping from the heap because we need to make sure that that's that at that price point there are orders, and then we'll be popping from the heap, and we're popping from the dictionary as well. That actually covers most of the cases where we do orders. And one more other case is that if the best price doesn't sufficiently meet the orders price, then at that point we need to return the amount of remaining quantity, which could be the full amount of stocks that the offer wishes to buy, and then we have to create a new uh, resting order for that in their respective book as well. So why don't we get coding for this? So first we need to import the heap queue model. This is native to Python. And first let's define some classes that we're going to use to do this order. So we're going to have a order class, def init. Let's have a constructor. Let's have a direction. So is this a bid or an offer? Let's have the person. Let's do some typing as well. Let's have the person. So this is the name of the person. Let's have the security. So what security they're wishing to buy. I think it'd be good to just have it inside the order as well. We'll have the price, so it's going to be an integer, the price that they're willing to pay or receive or sell for, and the quantity, so this is the amount of security that they wish to trade. So it's going to take in self, so let's just have all this, self.person equals person, self.security. Let's overwrite this dunder method, self.price is price, and self.quantity is quantity. Now that we've defined our order, let's also define a new class for trade. So this is if when a trade occurs between two parties, we still need to record this trade. So self, let's write down the buyer, it's going to be a string. Let's find down the seller, it's going to be a string as well. Let's write down what price. Now let's write down the security first. Let's write down what security has been traded, has been executed. Let's write down the price that is been executed for, and let's write down the quantity. So how many of this security has been traded. Similar to before, we're just going to construct these as well. Self.price equals price and self.quantity equals quantity. Now, before we actually start building the engine, I think it would be good to start writing one of these books first. So first, I'm going to write the bid book. So let's call it the bid book. And then we have a constructor for this as well. This isn't really a constructor, it's more of a initializer, I guess. It's more of an initializer than a constructor, but it's important to know this dunder method because it gets past the self thing. So for the bid book, it's not going to get past in anything. But as we said, we're going to have a heap. So let's call it max heap. So we know what type of heap we're working with. And we're going to have a book, which is going to be a dictionary. And then we said it's going to be an integer, and it's going to be have a DQ. Let's get some typing, import typing. Whoops. From typing, import dic, dictionary, import dic, and DQ. Now let's do a method where we're going to add a def add order. So self, and then at this point we're going to be receiving a bid, which is going to be a type of order, and it's not going to return anything. Now we're first going to check, is this bid.price in self.book? If not, This means that we've never seen a order for this given price point, so that a dictionary mapping will not exist in it will not exist in the heap as well. So let's first push it to the heap, heap push self.max heap, and then the bit.price. Let's also create a dictionary mapping for this price point as well. And we said we're going to use a DQ. We have to import that. From collections, import DQ. Cool. And then at that point, we can be rest assured that this bid price will exist both in the queue, both in the dictionary and the heap. And then we just have to remember to add this order to this price. Remembering that it is a queue, this will keep the time priority in check. Now let's create the match. So for a match, we're going to be receiving an offer, which is still a type of order. And let's say it's going to return a list of trades. So these are going to be all the trades that have been executed for this match. Now, one of the cases that I did talk about is that we need to talk about the remaining amount of stocks. And then as we write it out, I'm sure we can figure out how to do that. So first, let's write a list of trades. So these are all the executed trades. Now, the thing that we need to check for is that while our book exists, while book self.book exists, and there are more than zero, and there are more stocks to be trading as well, we're going to be going into a loop. At this point, instead we're going to use a max heap, but Python by default uses a minimum heap. That means, but simply we can just negate the price going in, and then if we negate it all, then the most smallest number will become the biggest number. So we can simulate a max price like that. But that does mean that when we do want to look at the number, we'll have to negate the number once again. So now once we got the best price, we need to check it. Is this best price greater than or equal to the offers price? Now that is one of the requirements here. In order for a trade to be occurring, the bid price, or the person who is willing to buy a security's price, must always be greater than or equal to the offer price. And if that is the case, we can get the list. We can now iterate through our orders. So let's do that. List of orders is going to be self.book, and then we're going to be looking at the best price. And then we do know that this is going to be a DQ, and it is going to tell us it is a DQ. But one of the problems, we'll actually make a shallow copy of this DQ, because we would have to be popping from this DQ, but we don't really want to pop it as we iterate. We don't want to mutate the DQ as we are iterating through it. So let's go through it. For order and list, a list of orders. So the amount of trades, so the amount of quantity to be traded will always be bottlenecked, will always be throttled by the minimum amount of trades that are being willing to be traded between the two orders. So it's going to be the minimum amount between offer.quantity and this order.quantity. So order is going to be, right here. Let me do some typing here. Yeah. Now once we've done that, we can subtract this amount of from the order amount to trade, and then the offer quantity dot amount to trade as well. This ensures that none of these two values will go beneath 0, because we can't, well, that's not what we should be doing. We should be fulfilling a order and then nothing else. We should be fulfilling the exact amount of trades that should be happening within an order. And let's create a new trade object that records this. So the buyer is going to be the bidder at this point, which is going to be the order.person, and the seller is going to be the offer.person. The security is going to be, we can get this from either, but let's get it from the order security. The price is going to be the best price, and the quantity is going to be the amount to trade. And then simply we can append this trade to our output list. Now I did say, now one of the things that we have to check here is that, let's see, if this order has been fully fulfilled, we have to ensure that we pop it from our DQ. So if order.quantity is smaller than or equal to 0, it should never be smaller than or equal to 0, but just have some stricter type checking. After just checking, we can do that. If that is the case, then we can simply self dot book, we can pop left from our DQ. Best price dot pop left. Now, if we've iterated through all our orders, another thing is, let's say all our orders in this DQ has been fulfilled, so this order is now empty. If that's the case, we have to delete it from our heap and our dictionary. So if not self.book best price, so this is asking if the DQ is empty, then we're going to be deleting it from our book best price, and then we'll also be popping from our heap self.heap. Now, what if the best price doesn't suffice for the offer price? Then we'll have to simply break out of this while loop, because we know if the best price can't suffice for this offer price, then no other prices beneath it can also be satisfactory. And at the end, we're going to return trades. But there's one more thing that kind of goes on of what I just talked of. Is let's say some offer quantity comes in, but our best price never suffices it. That means we need to create a resting order for the incoming offer. And how do we, and we can't really do that inside here because our scope is limited to the bid book. So this is something that we'll have to do on the step above. So we can also return the amount of remaining quantity. Yeah, we can return the amount of quantity from this offer. So we're not going to be returning a list actually, we'll be returning a tuple, where the first is the list and the second is an integer. So does that look good for a bid book? Now let's try do an offer book. Similarly for an offer book, we're going to have a minimum heap this time. And we won't be taking it in a bid, we'll be taking it in an offer. So let's go through it. Whoops. So min heap, push. We're not going to be negating it because Python is a minimum heap by default. And for a offer book, we do want the minimum. We also want the best price for a minimum for a offer book is the lowest amount of money that a buyer wants to pay. And let's look at our bid function. So it's going to be a bid, and we don't have to negate it. It's going to be a minimum heap, and then simp. Let's look here. So the bid price always has to be greater than the offer price. So we're just going to switch around the sign here. Yeah, so if a bid comes in, so this bid price, whatever someone's willing to pay, must be greater than the resting order, which is a offer at this point. Yeah, and then for the trade, we have to just switch around it as well. So our first parameter is actually the buyer, and the buyer here is going to be the bid.person, and the seller here is going to be the order.person. Everything else looks fine. Cool. Now that we have a bid book and offer book ready, does that look good for a bid book and offer book? Yes. Now let's go and create the matching engine. So it's called the initializer as well. It's not really a constructor, as I would say, because it has a reference to itself. And this is a dunder method, but another dunder method there exists as def new. So new is more of like the constructor, whereas init is not. But for the matching engine, it's not going to take in anything, but it's going to have a bid book. It's going to be a bid book, and it's going to have a offer book as well. So those two look good. It's also going to have a list of executed trades so that we can simply have a reference to all the trades that we have committed so far. This might be useful because we also need to let everyone else know all the executed trades. So let's say like A and B have done a trade. C has a right to the knowledge that A and B has traded as well. Well, I'm guessing C should be able to see all the other trades that have happened on the networks as well, so that C themselves can like price themselves well and find a good price. But other than that, let's do the match function. This is going to take an order. At this point, we don't know the direction of the order, so it's just going to be an order, and it's going to return a list of trades. And then just for this case, I'm just going to say that what it returns is the list of trades for this specific trade, whatever happened here, and it's not going to be the executed trades. We can just create another API. we can create another API if we do wish to know all the executed orders so far. So first thing, we got to check the direction of the order. Let's say if it's a bid, that means we have to go look inside the offer book. So we're going to look inside the offer book, but if the offer book is actually empty, this means that there's no point looking in the offer book, and we can simply add this bid offer into the bid book right away. But if there are orders, then we can simply do the match function that we created in the offer book. So it's going to return to us a list of trades and the remaining amount. Match, and then we're going to send in this order. We can extend the amount of executed trades by trades. And then we have to check here. If the remaining amount is more than 0, this means that this order has not been fully fulfilled. And if that's the case, we still need to create a, and if that's the case, we need to create a resting order for the remaining amount of stocks for this bid. So first things first, we got to update the amount of order quantity by the remaining amount, and then we can simply just create a new add order inside the bid book with this updated order quantity. If it's not a bid, then it is a offer. So for the offer, we're going to be looking at the bid book. So if the bid book doesn't have any outstanding resting orders in it, this means that we can simply add it straight away into the offer book. Else, we can do what we did up here. And then in the end, we're going to return trades. And then we'll just have to create what trades is up here so that it does have a reference. So cool. That looks like a good bid book offer book in a order book system for us. Let's try and code this out. Okay, so it's looking for the method execute. Quantity is going to be an integer. That is what we have said. Might be because the order is wrong. So the order that we're expecting here is, where is it? Direction, name, price. So we're looking for price. Quantity, and the security at the end. Oops, yeah, we're not be popping from the heap. We're going to be popping from the max heap. And down here, we're going to be popping from the minimum heap. Okay, so this code was made in mind of me using a dictionary rather than a heap. So I think there's some cases where we are looking at it, but it's fine. I can do some fixing here. So if it's a bit book, we're going to be clicking at the maximum heap, 0. Let's just go look at the cases where we're peaking. This is the bid book. At the bid book, we'll be looking at the max heap, so 0. This is the offer book. In the offer book, we'll be looking at the minimum heap, so 0. And for the last one, we'll be looking at the offer book, which has a minimum heap as well. So 0. Let's try to run it again. Okay. Too many values to unpack. No. Because this will only be returning 1 rather than 2. There we go. Let's try running again. And then what's the problem here? If we're in the max heap, we just need to negate this because our max heap isn't quite right. Now let's see. Test. Oh, yeah, we'll be looking in the bid book to match this. There we go. All passed.